everyone, we're going to evaluate the improper integral or state that it diverges. From 0 to 2, we have z squared times ln of z dz. Now, this is improper integral because ln of 0 is not defined at 0. So we have this form that our function continuous at 0 to 2. We have an infinite discontinuity at x or z equals 0. So we're going to use this form to evaluate our integral. So I'll write that out. That's going to be the limit as x, or let's call it t, approaches 0 from the right, that's given there, of our integral, and then we're substituting our 0 with t. So instead of 0, you're going to put t to 2. And then we have z squared ln of z dz. All right. Now we're going to integrate this. You can use integration by parts, or you can use this formula. So I'm going to use this formula here. It's a little easier. So if you, let's just do a little side note here. If you integrate this, we're going to do our u is z, so we're going to have 1 divided by, and our n is 2, so it's going to be 3. And then we have z cubed ln of z minus 1 divided by 3 squared is 9, c cubed plus c. All right, and then if you factor all this out, let's see, we can get, let's pull out the z cube. And let's go ahead and factor out a 3 squared. If I factor out a 3 squared, this is only 3 to the first power. So I'm going to go ahead and factor out 3 squared and call this 3 ln of z minus 1. So basically we factored out this. And I have to include this 3 because this was only 3 to the first power. So, and then you'd put the plus c. So that's the integration of that. It's a lot easier than doing integration by parts. So we're going to get the limit as t approaches 0 from the right of z cubed divided by, I'll just put 9, of 3 times ln of z minus 1. And we're evaluating from t to 2. All right. Let me put a parentheses there, or brackets there. All right. So now let's go ahead and start with 2. So we're going to write the limit. We're starting with our 2. The limit as t approaches 0 from the right. And when you substitute in 2, 2 cubed is 8. So you have 8 ninths times 3 ln of 2 minus 1. All right, and then for the t, we're going to get, let me move this a little bit, do this in a different color. We're going to get minus 1 ninth, and then we have t cubed, and then we're going to have 3 ln of t minus 1. All right. Now, as we take the limit for the first part, we're just going to get this piece here. So I can write this as 8 ninths times 3 times ln of 2 minus 1. Or we can go ahead and factor that out, but I'll just do that later. And then we have minus 1 ninth. And now we have to take the limit of this. So we're going to take the limit of, I'll just put L for here. I'm putting the limit for this because we're going to do this on the next slide. So basically, we have this answer here. We'd have to distribute this, but we're going to have to take the limit of this. So this is going to equal, let me rewrite it. We'd have the limit as t approaches 0 from the right of t cubed times 3 ln of t minus 1. All right. So what I'm going to do is use L'Hopital's rule to differentiate this. And I'm going to write this as the limit as t approaches 0 from the right, and write this as 3 ln of t minus 1 divided by t to the negative 3 power. So using L'Hopital's rule, we get the limit as t approaches 0 from the right. When you differentiate this, you're going to get 3 divided by t. So it's just 3 divided by t, and the denominator is going to be negative 3 divided by t to the 4th. So this simplifies to the 3's will cancel, and this t to the 4th can move up here. So this simplifies to the limit as t approaches 0 from the right, and it's going to be negative t cubed. All right. Well, this limit is just equal to 0. You just plug in the 0 there. So basically, our answer is, our integral is going to equal 8/9, or 8/3 when you simplify, ln of 2 minus 8/9. And real quick, I'm going to write what we had before. We had 8/9 times 3 ln of 2 minus 1. So when you distribute, the 3 goes into 9 3 times. And then when you multiply 8/9 times negative 1, you get that. So that's how I simplified. Thank you. Have a nice day. Bye-bye.